Okay, we are at, I think it's 23.3. I mean, I'm sorry, 32.3. Inductors. Oh, I lost my place. Um, Inductors in AC circuits. Yes, 32.3. Inductors in AC circuits. So let's share the screen. That's the last RMS current and voltage from uh, the last session. So let's look here. We have an inductor and an AC source. Delta V is equal to delta V max sine omega t. And we have current going through the inductor, I sub L, and delta V sub L. So we have VL, if you recall, when we studied inductors, it was E equals minus L didt. So here we have delta VL is equal to minus L dIL dt. Now we applied Kirchhoff's law. Delta V plus delta VL. Well, delta VL is equal to minus L dIL dt. That has to equal to 0 by Kirchhoff's rules. So delta VL, just solving the equation for delta V. Delta V is equal to L dIL dt, which is equal to delta V max sine omega t. And now DIL is equal to delta V max L sine omega t dt. Now, if we integrate sine omega t dt, we get minus cosine omega t minus 1 over omega cosine omega t. And we put that, well, here we have it, I sub L equals delta V max L. The integral of sine omega t dt is equal to minus, because the integral of sine omega t dt is equal to minus 1 over omega cosine omega t, we get equals minus delta V max over omega L cosine omega t. Now, cosine omega t is equal to minus sine omega t minus pi over 2. That's an identity. So we can write that I sub L is equal to V max, because it has a sign, because cosine omega t equals minus sine omega t minus pi over 2, we lose the minus sign. So IL is equal to delta V max over omega L sine omega t minus pi over 2. Now you can see that the current, that minus pi over 2, the current lags the voltage by 1/4 of a cycle. In other words, when at the beginning, when the voltage is 0, the current is at the negative maximum. When the voltage is max, the current is 0. So the current lags the voltage by 1/4 of a cycle. This may help you remember. This is not in the original PowerPoint. I added this. If you recall from the DC situation, as soon as if you have an inductor and hooked up to a DC supply, and as soon as you flip the switch, you remember the inductor, we were using a solenoid in the experiment. It's going to want to oppose the growing magnetic field, so it induces a current to oppose it. So at the beginning, the voltage is max and it decreases. The current is minimum and increases up to, once you get several time constants, then it just becomes steady state current. Don't worry about the shape so much as the idea as when you flip the switch, the voltage is max and decreases to 0. The current is min and increases to the maximum. Now let's go back here and let's just look at it from the A to B, certainly the voltage is max and the current is 0. So as the voltage diminishes, the current increases, and that's what we see in here. As the voltage decreases, the current increases. Okay, so here we have IL is equal to minus delta V max over omega L cosine omega T. I max is equal to delta V max divided by omega L. We know that in the resistive case, I equals delta V divided by R. X sub L is called omega L, where omega is equal to 2 pi times the frequency. X sub L is called the inductive reactance. We define that inductive reactance as omega L, where omega is equal to 2 pi F. So X sub L is equal to 2 pi FL. And I max is equal to delta V max divided by X sub L. So delta VL is equal to L di dt, DIL dt equals minus delta V max sine omega t equals minus I max X sub L sine omega t. Now let's look at this. Consider the AC circuit in the figure. The frequency of the AC source is adjusted while its voltage amplitude is held constant. When does the light bulb glow the brightest? It glows the brightest at high frequencies. It glows the brightest at low frequencies. The brightness is the same at all frequencies. Well, let's look at the equation. So it'll glow when the current, it's a function of the current. Low current, it won't glow as bright. High current, it'll glow brighter. So what determines the current? Well, it's equal to I max equals delta V max divided by X sub L. Well, X sub L is equal to 2 pi FL. So there's the frequency component in there. Since it's in the denominator, it's inversely proportional to the frequency. So if the frequency goes up, I max goes down. If the frequency goes down, I max goes up. Remember, it's 2 pi FL determines the X sub L. So for high frequencies, I max will be lower. For low frequencies, I max will be greater. So it's it glows brightest at low frequencies. And sure enough, there's the answer. And that is the end of the inductors in an AC circuit. The next time we'll go back to, we'll go to capacitors in AC circuits.